in this video, I'm going to introduce gases, and so just a couple of characteristics of gases that you should have covered in first year chemistry, or just kind of common sense as well. It's the fact that gases, they expand to fill the volume of a container. That's one characteristic. Another one is that they're highly compressible because there's a ton of space in between gas molecules. And since they're so spread apart, they actually act independently of each other. So they're not attracted to each other, and instead they kind of coexist. And we'll look at how that influences our mathematics a little bit later on when we're working with gas laws. Really quickly, to talk about pressure, pressure is the force that's exerted on a given area. So for example, if I'm stepped on by someone with wedge shoes versus stilettos, the amount of pressure my foot experiences, the force is the same, but the amount of pressure is much larger for the stiletto heel, and therefore it hurts a lot more because the area over which the force is exerted is much smaller. So that's why getting stepped on with stiletto heels hurts so badly. And the last thing to talk about is atmospheric pressure. Now, atmospheric pressure is the force exerted by the Earth's atmosphere. So right now, the atmosphere is actually pushing down on us. The gases in the atmosphere are pushing down on us, and we're experiencing that atmospheric pressure. Now, the barometer is one tool that's used to measure atmospheric pressure, and what it is, it consists of a tube that's filled with mercury, and the atmospheric pressure pushes down on that open bath of mercury that you see right there, which would then cause the mercury in the tube to rise up the higher the atmospheric pressure. And so one unit, I'm going to talk about units of pressure in just 1 second, but 1 unit of pressure is a millimeter of mercury, and the standard for that is 760 millimeters of mercury, because when you're at normal standard pressure, the amount of atmospheric pressure causes the mercury to rise up 760 millimeters of mercury. So one of the first things that you need to learn as far as gases are concerned is the units for pressure. Now, the units for pressure include millimeters of mercury, atmospheres, and then also kilopascals. So the relationship is that there are 760 millimeters of mercury in 1 atmosphere and in 101.3 kilopascals. So let's work on converting from millimeters of mercury into atmosphere. So I have 1,277 millimeters of mercury. That's my given. So I'm going to get out of millimeters of mercury by putting that unit on bottom. And then I'm going to get into atmospheres by putting that up top. Now all I have to do is put the relationship. So for every 1 atmosphere, there are 760 millimeters of mercury. And so I'm going to take 1,277, divide by 760, and what I get, I want 4 sig figs, so I get 1.680 atmospheres. Okay, so I've converted from 1 unit of pressure, millimeters of mercury, into another unit of pressure, atmospheres. We're now going to talk about the ideal gas equation. So the ideal gas law is PV. The equation is PV equals nRT. P being pressure, V being volume, N being number of moles, and T being temperature. Now, R is your gas law constant, which will be given to you, and it's 0.0821 liter, atmosphere, Kelvin, mole. And so the reason why these units are important, the liters tell you that your volume must be in liters. The units for volume must be liters. Your pressure must be in atmospheres. Your temperature must be Kelvin, and then moles must be moles. So in this problem, I'm given volume, I'm given pressure, I'm given temperature, and I'm asked to solve for the number of moles of oxygen. And so I'm going to be using the ideal gas law, so PV equals nRT. Okay. Remember, your R value, your constant, is 0.0821, and the units are liters times atmospheres over Kelvin times moles. Okay? So the pressure must be in atmospheres. So I have 2.3 atmospheres. Notice my volume must be in liters. So right now I have it in centimeters cubed, which is equivalent to milliliters. So I've got to divide that by 1,000 to get it into liters. So I have 0.0026 liters. And I'm going to set that equal to, well, I'm solving
for my number of moles, so N, times my R, which I have, which is given to me, so 0.0821, and then times my temperature. So my temperature right now is in Celsius. I need to convert that into Kelvin. And when I do that, I get 299 Kelvin. Okay? And so when I solve for my N, I multiply 2.3 by 0.0026, divide that by 0.0821, divide that by 299, and what I end up with my answer, having 2 sig figs, I get 2.4 times 10 to the negative 4th moles. Okay, so that's the first part of this problem. The next part of this problem asks me how many grams of oxygen is this? Well, I know how many moles I have. I have 2.4 times 10 to the negative 4th moles. And so I need to convert that into grams. So I'm going to put the moles on bottom, grams up top. This is molar mass. So since I have O2, the molar mass of O2 is going to be about 32 for every 1 mole. And so when you multiply this, what you should end up getting for the mass is 0.0078 grams. So there's my mass. I'm almost done. I have one last question, and it asks, what's the density? Remember, density equals mass divided by volume. So here I know my mass. It's 0.0078 grams. And I'm going to divide that by the volume. And the volume I was given at the beginning of this problem was 2.6 centimeters cubed. And I'm just going to keep it like that. I don't need it in liters for this part. Okay? And so when I do that division, what I end up getting is 0.0030 for 2 sig figs, and it's grams per centimeter cubed.